enhancement MOSFET, EKV small signal transconductance model. Already we have seen in the last video. Here in the non-linear operating point, here gates, source, drain, base. Here VGB, VGB not, VGB equal to VGB not plus VGB, VDB, VDB not, VDB equal to VDB not plus VDB, and then VSP, VSP, VSP equal to VSP not plus VSP, ID, drain current, ID equal to ID not plus ID, this ID, this VGB, VDB from equivalent circuit, linear equivalent circuit. We got from linear equivalent circuit here. Okay, got it. And then GMP, GMG, this one already we have seen. ID, partially differentiate drain current with respect in between gate and base, voltage of gate and base. There, VGB, drain current, that is in between here, voltage depends with respect to ID current. This current will flow. Okay. So here ID from linear equivalent circuit will take this ID, small ID, VGB, VGB, small VGB from equivalent circuit. So here from gate going from here flow, here a source, that's why VGB. Okay, here VSP from flow going here like this. Then here GMD, D going from here, UDB. Okay, then VGB, here, VSP, UDB. It means in between here VGP. Okay, in between VSP, here VGP, here VSP, in between source and base, source and base, VSP here. Okay, and VDB in between drain and base, from drain and base here. Okay, here VDB. Okay, that one VDB here. Sometimes I told UDP, sorry, I'm very sorry for that. VDP only, okay. And then VSP, VGB, okay. That is GM conductance, okay, okay, fine. Then here GMD already we have seen. Here GMD, where is the GMD? Train. GMD equal to in train. GMG equal to in gate. GMG. GMD here this part. Okay. Okay. So train current with respect to what? GB first, then DB, then SP, like that. Okay. Then ID, small ID. Okay. Then BDB, BDB. That is small only. Then remaining VSP, VGB equal to 0. Here also except VGB, VSP, VDB, all are 0, equal to 0. Okay. Then here GMS in source here GMS, here what is happening? Okay, that is this current, derivation of the current with respect to this current, ID current with respect to ESP. Okay, so small from equal circuit, small ID, small VSP. Okay, small VSP, remaining all are 0. VDB, we don't want other things, that's why we have to make here 0. VGB and VDB, VDB all are 0 and equal to NGMG equal to NGMG equal to GMS. Okay, then finish. And here, but here no, here only like this only, no like this cut NGMG like this. Okay, here also same, water same like condition. Here only different, NG source, NGMG. Okay, here GMG, that is what? Multiply with the number n, that's all, that is equal to value both, but here negative here, source negative only. Okay, source negative always. Okay, here what is positive? G is positive, base also negative, source also negative. Okay, then D also positive, so DG positive, SP negative, SP negative, TG positive. Okay, then in weak inversion, subthreshold. Okay, in subthreshold, in conduction and in saturation, in weak threshold, weak inversion, that is in subthreshold, here strong inversion, here GMG ID n multiplied with UT GMG, this value GMS NGMG. No, here IDF UT with respect to UT, GMD IDR with respect to UT. Okay, GMG ID GMS IDF for GMD IDR. Here in strong inversion, here weak inversion, in strong inversion what will happen? In GMG, beta VDB minus VSB, GMS 2n beta IDF square root. In GMD 2n beta IDR, that is in this will happen in gate, this will happen in source, this will happen in drain. Okay, in gate beta multiply with the drain to base voltage with source to base voltage, minus subtract, then multiply with B, then we will get GMG. Here 2 times N, that is yes, here 2 times N multiply with B and IDF. Okay, here 2 times N B, after this is only for scaling purpose. Here 2n beta IDR root, here FR. Okay, in gate is the main difference, dB minus SP, dB minus SP. That's it. In GMG conductance, that is here GMG. Okay, then no, first I told no, source only negative, they both are positive only. Okay, that means GD positive, BS negative. So, because these three only here, no base nothing. Then saturation forward, here GMG equal to ID number of times multiply with UT, and here ID UT in GMS, in GMD the lambda ID. Okay, here this is in saturation forward. Okay, here UT, here only different totally in train, in source and gate same, in numerator, denominator only, here number of times is multiplied with UT, n multiplied, that is number of times. Here GMG equal to 2 beta ID divided by n and square root total. It means square root for scaling purposes. Okay, reducing that value. Okay, that ID current multiply with B 2 times beta. After that find this value